welcome to the first episode of Calculus Chat. You've just met us in the welcome video, but to familiarize yourself with our voices, I'm Dr. Biggs.
I'm Professor van der Walt.
And I'm Dr. Kellerman.
So, let's start with a bit of a discussion about what is first year calculus about?
Well, that's a very good question. Go ahead, everyone.
No, I wanted to say I've not taught this module before, so I'm not the best person to discuss past experience.
But, you must have taken a first year calculus module back in the day at some stage.
Yes.
This is a pretty standard course in most universities. They throw you in first year, and the first thing you learn in maths is calculus.
Well,
now,
I think
calculus is not the only area of mathematics, and I encourage everybody to go and check out the video on our Padlet, the map of mathematics, that gives you a little bit of context. But, there's probably good reason for why we study calculus as the first thing in university.
Yes, I think of differentiation and integration.
Yeah, well, it's if you're going to do any kind of applications of mathematics, then you're going to need calculus. Right? So calculus, it's kind of like the science of change, or the mathematics of change. It describes how things change. And this is at the core of how we model the world around us these days. Well, for the last, almost 400 years.
Yeah.
Yeah.
This has been a humongously successful a piece of maths that has gotten applied, and early on specifically in physics for modeling, and it's just amazing how well it's worked in many areas: physics, biology, engineering, economics. So often actually the pressure also comes from outside of maths, that we need our students to differentiate and to integrate, because these are fundamental tools that they need.
Yeah.
And I guess that is basically what first year calculus is about, is getting into, what is the derivative, mainly exploring that a little bit more in depth maybe than some students have seen it before, developing it from the perspective of the limit, and what is the integral. Sticking, of course, to single variables, but then getting a little deeper into those concepts.
Yeah.
I would say also it's to prepare students for more advanced analysis courses.
Yes, that's
So first year
true.
calculus is the foundation upon which subsequent analysis courses are built. But maybe someone can just explain what analysis is in mathematics to a student who might not have encountered the term before.
What is analysis? Now that's a tricky question, I would say.
Well, look,
Jan Harm, you're the analyst.
okay, well, I can say a few words about this. Look, so analysis would not exist if it were not for calculus. Right? So Newton and Leibniz and those guys came up with this idea of calculus, these fundamental things. And, in the beginning, they developed this in a less formal style than we are used to as mathematicians these days. But this led to all sorts of inconsistencies. It's well known that people like Euler and Cauchy would sort of, have a series converging in one paper, and then 5 papers later the series would be divergent. And this really convinced mathematicians, or a lot of mathematicians, that we need to be more precise. We need to have better definitions to sort out these things. So it kind of gave birth to analysis. So analysis is kind of the foundations of calculus. So I think in 114, we're going to assume a lot of things. And then those foundations that we're kind of assuming, that we're kind of hiding, you can say, will be developed further in analysis. So analysis you can kind of think of as the theory of calculus. At least that's one perspective.
Yeah, and they will see that in the second semester. They'll see that if they do some second year mathematics, we have advanced calculus, and we start a bit with real analysis and various topics. If you're just talking analysis, there's real analysis, there's complex analysis, there's all kinds of analysis where this idea gets taken further and further.
Yeah, but they all have at their foundation calculus.
Yeah.
Yeah.
But the point that I like you made, the point you made that I liked was that there's a long history to this, right? Nobody just came up one day and thought, "Ha, this is how we do it. Brilliant. Let's write this down."
No,
This
absolutely.
took centuries to develop nicely into a theory,
Yeah.
and what we cover in this course is actually centuries worth of work. And that's a good context, I think, for our students to have, because sometimes you can feel a little lost. There's a lot of concepts coming out, and why are they defined this way? Well, often it's because of centuries of
Yeah.
tinkering with those ideas and playing around with it that we came up with, well, this is the best way
Yeah.
to do things in a way that is extremely useful in a wide array of places.
Yeah, absolutely.
Like, I just want to say, it was many of the greatest mathematical minds over the past few centuries who contributed to calculus as we know it today.
Well, even, I mean, some of the concepts or some of the underlying ideas in calculus, for instance, in terms of expressing areas as sums and refining these sums, this idea was known to Archimedes, and I mean, he lived 800 years before Newton.
Yes.
Yeah, so I
And
mean,
I mean, even the derivative and the integral was sort of developed before we even had the concept of limit.
Yeah.
The limit came in when we wanted to put it a little bit more formally to develop the analysis side of it
yeah,
and to organize it better.
yeah, yeah. But so I think it's a very important point you made, Rory, that we are really compressing hundreds of years of mathematical thought and development into a semester. Um, it, so that sounds terrible. But on the other hand, we are distilling that which worked. So there were a lot of things that people tried that didn't work or turned out not to be important. So we are kind of distilling that which worked into a semester.
Yes. No, and I think in a way that is quite wonderful.
Yeah.
So yeah, we're going to have a lovely journey through calculus, differentiation and integration in single variables in this course. Okay, but these are special times with the COVID-19 pandemic, and things are not quite as we've always had them, right? This is a time of some big changes, and I'm sure that's going to be some lasting and affecting changes, but this means that we're not going to have the traditional first year experience, maybe, right, in terms of face-to-face lectures and that. So maybe we can talk a little bit about what is our plan and well, what are some of the disadvantages and advantages, perhaps, of doing things this way?
Yeah, it's certainly a big break from what we're used to. I mean, I think for all of us who had to start teaching in this way halfway through the first semester last year, it was certainly a big adjustment. And for the students as well.
Yeah,
I mean,
and we're still learning good ways of doing that.
yes, absolutely. I think it was for the students. It's a big shock that you all of a sudden. I mean, there's you are responsible for pacing yourself in terms of how you study. I mean, there's not a lecture that happens every that you have to go to, and then the lecturer tells you what you're talking about. I mean, you have to go and you have to go look at the videos yourself, and it takes a lot more responsibility from the students. But on the other hand, I think
But it can also work very well. No, I was just saying it can work very well. I've seen some students thrive in this online mode. So if you take advantage of what the mode offers in contrast to the traditional contact mode, you can actually thrive in these circumstances. It can be very rewarding.
Indeed, and I mean, well, let's start there with how will our lectures actually look, right? Usually, you'd all get into a big lecture hall. The lecturer comes in. It's a nice discussion, maybe, and well, the lecture happens. But for us now, we're going to be doing it as online videos, right? They're not going to be live. They're going to be pre-recorded, and the plan is to put some questions in there. Where you are supposed to pause and try out those questions yourself, much like we would do in an actual lecture, right? In a lecture, we pause and we tell students, well, think about this. What do you think? Try this. And we engage those students to respond. And I guess, well, now the responsibility is even more on the students to make that pause, to think, and not just to run through the entire lecture, but actually pause the lecture and try the problem that we are suggesting that they try. And I think this does afford some serious advantages to some students, because now you can pause the lecture at any time. You can rewind. You can even, and this is a feature I like quite a lot, make the lecture run faster or slower. You can run it at half speed if you think somebody's speaking too fast. Or if you think they're going too slow, you can run it at 1.5 times speed or 2 times speed, right? The things that, oh yeah, let's get through it. So I think there's a wealth of opportunity here.
Yeah.
But you need to take responsibility for that. And it can work very well if both us and our students put the effort in.
Yes,
Yes,
I
maths
think.
is not a spectator sport.
Oh, absolutely.
Indeed.
To try to learn maths by watching someone else is like trying to learn a musical instrument by watching someone else. You have to get involved.
I like that analogy, and it's like, oh yes, you just move your fingers a little bit. I could do that, but when you actually have to do it, it's a different matter entirely. And so, well, on the topic of getting engaged, right? This is why tutorials play such an important part in mathematics, because that's where usually we all get together, we sit down and we try and tackle some problems, right? And it's important for our students to sit down and try that problem and struggle with it. And you will struggle with problems. And this is good, because it's in struggling that you learn. But sometimes you'll get stuck.
Yeah.
And getting stuck can be extremely frustrating. And that is the purpose of a tutorial, is to have somebody just help you find what is that next step. What is that one insight to help you go one step further so you can get unstuck. It's not to solve the problem for you or to give you a recipe for what to do. It's just to help you get unstuck and move forward.
Yes, absolutely. And I think the tutorials, and you'll see you'll be getting some weekly homework assignments with problems that you have to hand in at the end of the week. And well, those first of all give you nice practice. You know, it helps you to see, well, how well do I understand something? But those problems, they're an important opportunity for you to be wrong. And being wrong is important, right? Because we all make mistakes. I do not know a mathematician in the world who just sits down in the morning and writes down his proofs. Right? The morning that happens, you see that by several sleepless nights of trying to figure out what's wrong and trying to fix their mistakes. Right? So making mistakes and learning from your mistakes, that's really important. It's an important part of developing your mathematical skills. I don't know if you agree with that, Rory or Ruan.
I absolutely agree. I couldn't have said it better myself. And me and Dr. Kikianti are also making a video about this to expand on that point a little bit.
Ah,
And
excellent.
it is mistakes are essential.
Yes.
They are where we learn. So I would say you should be worried if you're not making mistakes. If you're just doing everything right, it either means you're cheating because you're copying somebody else's stuff, or you're not learning anything. You're wasting your time. You've already mastered the material.
Yeah.
Now, true learning takes place when you struggle. If it's easy, then you're not really learning. So
Yeah.
if you find if you find that you have to wrestle with it, it means you're actually learning something. But it's important,
Yeah.
I would also say, to keep up to date with the work and not fall behind.
Indeed.
Yeah.
So attend those tutorials, do the work. I think that's one of the reasons why there is a perception that university mathematics is more difficult than school mathematics, is perhaps simply that at university you get micromanaged less. You need to take more personal responsibility, and what often happens is students fall behind because it's relatively easy at university to not work in the short run. And then it
Yeah.
becomes so onerous a task to catch up that the students simply can't recover. So just very important to keep up to date with the work every week.
Mm.
It's a bit like you need time to assimilate the ideas and have to constantly expose yourself to the mathematics.
Absolutely. I
Absolutely.
agree wholeheartedly. And once you get behind it, actually, it takes more time to catch up than it would have taken just to stay up to date.
Yeah.
And then you get into a vicious cycle that you need more and more time to get back up to speed. And yeah, that I've seen a few students, unfortunately, fall down that hole. So on that note, I definitely want to say I want to encourage all our students to engage. Even though we are doing many things online, we are trying to make the best of that situation. We're going to have a Discord server, we'll have a Padlet, we'll have a Signal message group, we're going to have these live tutorials, right? So absolutely there are going to be a multitude of opportunities to come and interact, to come and discuss your problems, and to discuss it also among your fellow students, right? Often, especially as teachers, we know it's when you explain an idea to somebody else, when you're forced to try and view it from that perspective, that you actually form your best understanding of what's going on.
Yes, that's true. Just to latch on to what Ruan was saying, one of the great dangers of this online learning is exactly that it is so easy to fall behind. It is so easy to say, ugh, I am tired, or, I don't want to get up now. I'll watch the videos tomorrow. But tomorrow there are some new videos to watch,
Yeah.
right? So that's a great danger. So that's something you have to guard against. If you fall behind, it's very difficult to claw your way back. And something else that everyone said that I think is important is the difference between high school mathematics and what we do at university. And one important aspect is, as everyone said, that yes, there's nobody micromanaging you here. There's no teacher checking you on your homework. Your mother is not going to make sure you go to school today. So you have a lot more freedom, but with freedom comes responsibility. But I think the other important point is that I think high school mathematics is to a good extent very procedural, right? That this is how we solve this problem. This is how we do this kind of sum. Whereas I think at university and in 114, there's a far greater emphasis on understanding, and on understanding the concepts and being able to reason with those concepts in a rigorous mathematical way. And I think that's a big departure from say high school mathematics.
Yeah, we definitely expect much more from you than just merely being able to memorize. And I mean, in the context of online things, right, you have access to so many resources at your fingertips. The point of being a human in this context is to understand and being able to process and reason with that information. So, I mean, often it's not about just getting to the right answer. You might get to the right answer, but if your reasoning is flawed, you might still get a failing grade for what you answered.
I would also recommend to students when they read the textbook, they should try and preempt. Don't just read it, but try and preempt what the next step will be, or before you look at an example in the textbook, contemplate how you would solve it. Before you look at the example, try to preempt the next step. If you see a theorem, before you read the proof, think how you might prove it first, and even try and preempt the theorems that you might encounter in the textbook. So ask yourself, if you were the mathematician developing this material, what kinds of results would you need to make sense of it all? And that really helps to understand the work if you're not a passive spectator, but you actively try to preempt the next step, the next proof, and so on.
And I mean, on that note, if you really get into this material, right, and you start mastering it, it can be incredibly fun. I mean, this is the reason we are mathematicians, because it's beautiful. We love it. We can't think of doing anything else. But this comes with mastery, right? So if you're struggling, then it might seem less interesting. But if you can actually spend the time and make sure you are mastering every topic, you really start getting to the heart of the matter and start having a lot of fun and seeing the beauty. So certainly, please join us in that fantastic fun.
Yeah. I mean, it's kind of like a voyage of discovery. I mean, we're taking you on a tour of some of the most beautiful ideas in mathematics that were developed over the last 500, 600, 700 years. Come with us. It's fun.
Please do. Okay. I think that's just about it for this session. But let's finish off with quickly just saying what's going to happen in the first week, right? We're going to start laying foundations for what we want to develop, right? We're aiming to get to the differentiation and integration, but to do that, we need to first agree on a common language. So we're going to start with basics. What are numbers? We're going to start in the second week getting into functions, and once we've developed that base after the first theme, then we can start developing the mathematics towards differentiation.
Yes, and there's some interesting things happening in this first theme already. I mean, we're going to be introducing you to a new way of measuring angles.
The only way of measuring angles, really, if you want to do calculus.
The right way. Let's just say the right way of measuring angles.
Radians.
Yes, I would caution students, they might think that they know this material from school, like inequalities and absolute values and all, but there's a reason it's being done again. Do not skim over the work that is done in the first few weeks. Do not mislead yourself into thinking that you already know it.
Indeed, I think that is something that is amazingly easy to do in mathematics, especially if you haven't done the work. You see a solution, you're like, oh yes, I could have done that. That makes sense. But actually having to be able to produce that is another matter entirely.
Yeah.
And you haven't worked towards understanding the material if you haven't sat down and actually dug into those problems.
Now, we're doing in the first theme things that are familiar to a lot of you, but we're going to be looking at them a little bit more deeper than you would have at school. And so it's the same thing, but with a little bit more sophistication added on.
And sometimes from a slightly different perspective.
Yes, and from a different perspective. That's right.
Okay, well, I think we have a beautiful journey ahead of us in this course. And we look forward to taking this journey with you. And we hope you will enjoy this and engage with us. And ultimately that you will be successful in this module. Well, I guess we'll see you online. Cheers.
Bye.
Bye.